Hi everyone, this is going to be the first video of the series of videos on properties of triangle. In the first video, we are going to discuss about the fundamental attributes and some basic properties of triangle. So let's get started. Here I have a sample triangle in the diagram, triangle ABC. Now if we want to talk about the basic attributes of a triangle, the first thing that we need to talk about is the vertex. A triangle has three vertices. In plural it is vertices, in singular it is vertex. The three intersection points of the sides, those are called vertex, right? So in this example we have vertex A, vertex B and vertex C. So there are three vertices, they are A, B and C, uppercase A, B and C of course. And then a triangle also has three internal angles. The standard notation for the internal angles are uppercase A, uppercase B and uppercase C if the triangle name is ABC. Sometimes we use the angle symbol, sometimes we may not even use the angle symbol. If we simply say sine of A, that means we are talking about sine of the angle A. Now the angle is named after the name of the vertex. For example, this angle right here will be called the angle A, and then the angle right here it will be called the angle B, and the angle right here it will be called the angle C. So the vertex that contains the angle is named after that vertex, right? Now let's talk about the sides. Every triangle obviously has three sides. The length of each side is denoted by a lowercase letter, and that lowercase letter is indicative of the opposite vertex. For example, in this diagram we have side BC where I have written a lowercase a. That lowercase a indicates it is the length of the side BC. Now why A? Well, because it's opposite to the vertex A. That is why we denote the length of the side which is opposite to the vertex with a lowercase letter similar to the uppercase letter, right? So here we denote A as the length of the side BC. Similarly, the length of the side AC would be lowercase b, and length of the side AB would be denoted by a lowercase c. These are pretty much the standard notations for a triangle. Now let's talk about the next property, is the sum of internal angles. For a triangle, the sum of all three internal angles is actually equal to 180 degree or pi radian. Since we are referring to the angles as internal angle, do they also have an exterior angle? Actually they do. For example, if we extend the side BC from the point C, the angle that we are going to get right here, this will be called an exterior angle, and this exterior angle will be equal to the sum of the two furthest interior angles, which are A and B for this particular example. So this would be A plus B. Similarly, if we extend the side AB from the point B, there also we are going to get an exterior angle, and the size of that exterior angle would be sum of the two furthest interior angles, which are angle A and C. And also if we extend the side AC from the point A, we are going to get an exterior angle there, and that angle will be equal to the sum of two furthest interior angles, which are angle B and C. Now if you are thinking why is it like that, how to prove it? Well, let's name this side, the extended BC, let me name it as D. For example, here is a point D, so I am giving a name D right here. Now here you see the sum of the interior angles is equal to 180 degrees, so let me make a quick note here. And similarly, the exterior angle ACD, so let me say exterior angle ACD plus the interior angle C, that is also equal to 180 degree because that's a straight angle. Now from these two equations we can clearly say that the left hand sides are equal. So from here we can say angle ACD plus angle C is equal to angle A plus angle B plus angle C, and this will cancel each other, and from here we get angle ACD equals angle A plus angle B, and that's the proof. And similarly you can prove the other ones also, is the exact same approach. So an exterior angle is equal to the sum of the two furthest interior angles. Let's talk about the next property, which is the perimeter of a triangle. Perimeter will be equal to the sum of the three side lengths. Now there is one very important term here which is called semi-perimeter, and it is actually denoted by lowercase s, and that will be equal to half of the perimeter, which is A plus B plus C over 2. Next, let's talk about the types of triangle. How many classifications we have of triangle? Let's see that. we have two types of classification. One classification is based on the size of the internal angles and the other classification is based on the side length. So let's first talk about the type of triangles based on the size of the internal angles. When all of the internal angles of a triangle are acute angles, we call that triangle an acute triangle, or sometimes it may be called as acute angled triangle. Generally we call it as acute triangle. The next type of triangle is called obtuse triangle, when one of the angles is an obtuse angle. Now if you are thinking that, hey, can we have more than one obtuse angle inside a triangle? Well, that's actually not possible, because the sum of the interior angles is equal to 180 degree, and if we have two obtuse angles, both of them will already be greater than 180 degree, and then we also need to have a third angle, so that is actually not possible. So we cannot have more than one obtuse angle, but we can certainly have just one obtuse angle in a triangle. And if we have a triangle like that, it is called an obtuse triangle. And the third type here is the right triangle. When one of the angles of a triangle is 90 degree, we call that triangle a right triangle or right angled triangle. Here again, if you are thinking that can you have more than one right angles inside a triangle, that is again not possible, because if we had a triangle like that, then those two right angles will give us 180 degree angle already, and then of course we need to have a third angle, and the third angle size cannot be 0, so we really cannot have two right angles inside a triangle. We can have only one at the most. So if a triangle has a 90 degree angle, that triangle will be called a right triangle or right angled triangle. So this classification was based on the size of the internal angles. Now we are going to look at the types of triangle based on the side length. The first type of triangle based on the side length is called a scalene triangle. For scalene triangle, all sides are of different length. None of the sides are equal to the other one. So here I have denoted as A not equals B not equals C. They are of different length. The next type here is called isosceles triangle. When any two sides of a triangle are of equal length, then that triangle is called an isosceles triangle. So we can denote it like this. We can say either A equals B, or B equals C, or C equals A, right? Or A equals C. So any two sides of a triangle being of equal length, that triangle will be called an isosceles triangle. And the third type here is called the equilateral triangle. For an equilateral triangle, all sides will be of equal length. So we can denote it like this. Side length A will be equal to side length B will be equal to side length C. All sides are of equal length. And this type of triangles are called equilateral triangle. Next, let's talk about triangle inequality. The triangle inequality says that the sum of any two sides will be always greater than the third side. So can we denote that like this? And also from here we can derive another set of inequalities. Now let's take a look at this. From the first one, if we subtract A from both sides, then we are going to get B greater than C minus A. Now because we don't know whether C is greater than A or A is greater than C, so we are going to use an absolute value sign. So we can say B will always be greater than C minus A. And similarly from the second one, we can say that C will be greater than A minus B. And from the third one, we can say A will be greater than B minus C, and these are called the triangle inequalities. Next, let's talk about area of a triangle. Area of a triangle is usually denoted by the uppercase delta letter, which looks like a little triangle symbol, and we know that the area of a triangle is equal to half times base times height. Now from this diagram, if we consider BC to be the base, then what would be the height? Well, height will be a perpendicular line drawn from the vertex A onto BC, which is going to look like this. Now the length AD will be called the height when BC is the base. The height is always height of the vertex opposite to the base. So in this case, if BC is the base, then the opposite vertex is A, and we have to find out what is the height of A. That means the perpendicular distance between A and BC. Let's name it as H sub A. I want to use lowercase letter h to indicate it's the height, and I'm using a subscript A to indicate that this is the height of A from the opposite side. So then in this case, can we write it as half times BC is considered the base, and that length is denoted by lowercase a. So we can say half times A times height, which is H sub A. And if you think about it, H sub A over AB is actually sine of the angle B. Now from here we can say that H sub A is actually equal to AB times sine of B, and that is nothing but, what is AB? Well, AB is actually lowercase c, that's the side length C, times sine of B. And if we use this value of h sub a, over here we will get this is half times a times c times sine of b. So we can write it as half times a times c times sine of b. Similarly, we will be able to prove that this will be also equal to half times a times b times sine of c, and also it will be equal to half times b times c times sine of a. To prove the other two cases, we have to drop a perpendicular from B onto AC, and also we have to drop a perpendicular from C onto AB. Then we will be able to calculate the area of the same triangle, and they all will be equal, right? So as you can see, the area of a triangle is actually half of the product of any two sides and then times the sine ratio of the angle contained by those two sides. Now let me also highlight this particular form in a yellow box, and from there we should be able to derive another interesting relationship. So from here we can say that delta is equal to half times a times h sub a, and from here we can say that h sub a is equal to 2 times delta over a. So if the area of a triangle is given and one of the sides given, then if we have to find the height of the vertex from that side, that will be 2 times the area over the side length. And similarly, we should be able to derive that h sub b, the height of the vertex b from the side AC, that will be equal to 2 times delta over b, and similarly h sub c will be equal to 2 times delta over c. There is also another formula for the area of a triangle. Let me make a quick note right here. It's called Heron's formula, named after the Greek mathematician Heron of Alexandria. Heron's formula is used to calculate the area of a triangle when only the side lengths are given. And what is that formula? The formula says the area of a triangle is equal to square root of s times s minus a times s minus b times s minus c, where a, b and c are the three individual side lengths and s is actually the semi-perimeter. So here s is actually a plus b plus c over 2. I have already created a separate video on Heron's formula. I have shared the link in the description. Feel free to watch that video. There I have derived this formula. Let's also quickly talk about 4 important points related to a triangle. But before that, let's quickly talk about a new terminology called median. In a triangle, suppose we have a triangle here ABC. In that triangle, if D is the midpoint of BC, then a line joining D with the opposite vertex would be called a median. Similarly, if we join B with the midpoint of AC, that will also be another median. Also, if we join C with the midpoint of AB, that will give us the third median. So a triangle can have 3 medians, right? And this is one very important property, as you can see in the diagram, that all the medians are actually intersecting at the same point, at a single point. And that point is actually called the centroid. So lines joining the vertex and the midpoint of the opposite side, they are called medians, and the point of intersection of the medians is called the centroid, and it is denoted with an uppercase G. So what are the medians here in this diagram? Well, in this diagram, AD is a median. So let me make a quick note here. And then of course BE and CF. Those are the 3 medians for this particular triangle, and G is the centroid. Next, we are going to talk about the perpendicular bisectors of the 3 sides which meet at a point which is called the circumcenter. So suppose we have a triangle like this where the 3 sides are AB, BC and CA, and we have drawn perpendicular bisectors for each of the sides, right? So suppose the point where the 3 perpendicular bisectors meet each other, let's call that point as O, and that point is actually called the circumcenter. Now why circumcenter? Because from that point, if we take the distance of any of the vertices, then that will be the radius of a circle that will kind of circumscribe this triangle, and the circle is going to look like this. This circle is called the circumcircle, and the point O is called the circumcenter. I am going to create separate videos on each of these centers, how to find their coordinates and etc. All the details will be discussed in separate videos. In this particular video, I am just providing quick summary notes so that we are kind of familiar with this terminology. Next, let's talk about incenter. If we have a triangle ABC and if we draw internal angle bisectors, like we have the yellow dotted lines here, they are the internal angle bisectors. I have drawn them in such a way that each of them is bisecting the angle the internal angle. Now all of those internal angle bisectors will actually intersect at a single point, and let's call it as I, and that point is actually called incenter. Why? Because from that point, if we drop a perpendicular onto each of the sides, then those sides will be of equal length, and then we should be able to draw a circle which will kind of be inside the triangle. The triangle will kind of circumscribe the circle, and the circle will be inside the triangle, and the circle is going to look like this. So as you can see that the internal angle bisectors will meet at a point from which we should be able to draw a circle inside the triangle, and that circle is called the incircle, and the center of that circle or that particular point of intersection of the three internal angle bisectors is called the incenter. Finally, let's talk about orthocenter. For a triangle, if we draw perpendicular from the vertices, suppose we draw a perpendicular from the vertex A onto the opposite side BC, and let's suppose that perpendicular is AD, and similarly we drop another perpendicular from B onto the opposite side AC, and let's say BE is that perpendicular, and also CF is the other perpendicular. These are called altitudes of the vertices from the opposite sides. Now when you draw altitudes like this, they also intersect at a particular point, and that point is called orthocenter. Here I have denoted that point as H, and that point is called the orthocenter. So orthocenter is actually the point of intersection of the altitudes drawn from the vertices onto the opposite sides. I will create separate videos on each of these important centers here, like we have the orthocenter, the circumcenter, the incenter, and the centroid. I am going to create a separate video on each of these topics, and there I will describe how to calculate their coordinates using coordinate geometry and some of their main properties, right? Now this video being the first video of a series of videos that I am going to be creating for the properties of triangle. Next video will be on a couple of important theorems on triangle, and after that I will go into the actual relationship between the angles and the sides, which are part of the trigonometry topic, properties of triangle. I hope everything made sense. Thank you for watching. See you in the next video.